In this lesson, we're going to investigate a postulate for similar triangles. So in the last lesson, we talked about polygons of different side lengths. Now we're going to focus more on the triangle and determining whether or not triangles are similar to one another. So one of the tools that you need is your protractor, and you also need a straight edge. We're going to start by drawing two segments. One will label AB, and the other one we're going to label A prime, B prime. And I'm going to make one segment noticeably bigger than the other. Move my protractor there. And we're going to measure an angle. I'm going to measure a 30-degree angle right here. So a 30-degree angle. And as you can see, oopsie, let's, I'm going a little crazy here with my protractor. I think I can put my protractor away there. Use my 30-degree angle right here. And then what you're going to do is you're going to measure another 30-degree angle for segment A prime, B prime. I'm going to use a little bit of white out here. Thicker marker. I'm going to group that all together so you don't lose it. And now I can move it right here. And I can even make my segment B just a little bit longer now. Okay, so hopefully you measured a 30-degree angle, a 30-degree angle. So draw an angle at A and a congruent angle at A prime. So we've got our 30-degree angles at A and A prime. Now it says draw any angle at B and a congruent angle at B prime. So I'm going to have to pull the protractor out again, and I'm going to have to measure an angle at B and B prime. So I line up my protractor. Don't want that side. It might be easier for me to start at B prime this time. See if I can flip it. Okay, so now what I've measured, I've measured a 40-degree angle. I'm not quite sure what you made your angle to be, but I made a 40-degree angle and a 40-degree angle right here. So I have 30 degrees 40 degrees. You can see it says it backwards. It's a bit challenging for me on a smartboard. And then that's going to make, using the triangle angle sum theorem, that would make this angle 110 degrees. And the same with this angle, 110 degrees. So you can see that all three angles are congruent, all three angles are congruent. Now what it would like us to do is it would like us to measure each pair of corresponding angles. It does ask us if angle ACB, here's angle C, if angle ACB is congruent to angle A prime, C prime, B prime, and it is indeed from the triangle angle sum theorem. It says all three angles in a triangle have to add to equal 180. So now I'm going to take out my ruler, and you can use your ruler that's on your protractor, or maybe you have a ruler like I have that's just a ruler. I got a couple rulers up there now. Pull that down here. Oh, let's see if I can't pull it down here. Okay, I've got my handy dandy ruler, and I'm going to measure in millimeters. So my length AB is 45 millimeters. So I'm going to jot that down. 45 millimeters. And my length A prime, B prime I think what I could have done here with my little look at that. I'm going to keep this here, and I'm going to measure all three sides. While I can. It looks like my other side is from A to C is about 30 millimeters. Since I'm at an angle here, I'm going to measure the corresponding side A prime, C prime. And that looks like it's going to be 40, 53. Maybe 53 centimeters, 53 centimeters. We'll try 53 centimeters. Maybe 52 centimeters. Try 52 centimeters. Millimeters, rather. And then I'm going to measure this length over here. And it looks like this one is measuring 78. So A prime, B prime, maybe 78 millimeters for A prime, B prime. And then we got to angle it and drag it. And this looks like it's about 42 C prime, B prime, C prime looks like it's about 42 millimeters. Drag this over. Over here. And it looks like I'm getting 20. Measuring is kind of tough here, especially on the smartboard. 20, maybe 24 millimeters. Now this isn't the best way to measure because it's not very accurate. But I think I said 24 millimeters. Because if you're off a millimeter or two, it's going to have a little bit of an impact there. Are the ratios computed in step 3 approximately the same? Well, I'm going to use my calculator to take 45 and divide by 78. And when I take 45 and divide it by 78, I'm getting about 0.577. So I'm going to show you the first ratio is approximately 0.577. The next ratio, 24 divided by 42, is about approximately 0.571. And 30 divided by 52 is about 0.577. So you can see that, and this was just approximation. So you can see that if I went out to the nearest tenth, these would all be 0.6, 0.6, 0.6, 0.6. Because my accuracy didn't, it was with a ruler, trying to be accurate to the third decimal place is probably not very fair. So if I were to say, okay, well, I measured to the nearest tenth or to the nearest millimeter. So going out to the nearest tenth for the ratio would be a little bit more realistic. And they are indeed approximately the same value. What does that mean? Well, what we just did was we created two triangles that had two congruent angles. We measured 30 degrees, we measured 40 degrees, we made a triangle. We measured 30 degrees, we measured 40 degrees, we made a triangle that was a different size. What we ended up with is two triangles that are different size, but they have the same exact shape. Not all triangles have the same exact shape. They have to have all of their angles congruent, and their sides have to be proportional. Well, our first postulate says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles have to be similar. For example, given in this picture, we have two triangles. We have this right triangle, KHO, and we have another right triangle, GFO, and we want to prove that those two triangles are similar to one another. Well, they have to be similar according to the postulate because angle 1 and angle 2 are vertical angles. That's going to give us two angles in one triangle congruent to two angles in another triangle. These two triangles have to be similar now. They're going to want us to prove that if angle H and angle F are right angles, that HK times GO is equal to FG times KO. What I'd like you to do is I'd like you to kind of think about this. How would you go about planning your proof? Go ahead and hit pause. See if you can come up with an idea. Jot it down, and we'll talk about it. Okay, so what we have here is we have two angles that are right angles, and we want to prove not the angle-angle similarity postulate. We want to prove that HK times GO, so side length HK multiplied by side length GO is equal to FG times KO. We can use the postulate to prove this, this property of proportions that we're going to have to prove or get to. So we're going to start with the given information. Angle H and angle F are right angles. That is given. And then we do know that angle 1 and angle 2 are vertical angles and that those are going to be congruent. Now, if I can prove that angle H is congruent to angle F, I'm going to have two pairs of angles congruent to one another. So that's where I'm going to go next. I've only listed one pair of angles here. So we have one pair of angles. We're going to need another pair of angles. So we're going to go through this saying, well, angle H and angle F both have to equal 90 degrees because they're defined to be right angles. And if they both equal 90 degrees, then they have to be congruent to each other. That's a definition of congruent angles. And now in my proof, since I've listed two angles, two pairs of angles are congruent to one another, I can use the angle-angle similarity postulate to say that the two triangles are similar. Now, very important how we line the triangles up. HKO, so I'm starting at the right angle, I'm going up the longer leg and then down to vertices O. So HKO. That's going to correspond to FGO because HK is the longer leg of this right triangle. FG is the longer leg of the right triangle. Those are going to need to correspond together or correspond with one another. So I have HK corresponding to FG. So I'm going to write it in that order. Triangle HKO is similar to triangle FGO by the angle-angle similarity postulate. Now that I've stated the two triangles are similar, I can go back based on the definition of similar polygons or similar figures, and I can create proportions. So the proportion that I want to create is going to involve HK, FG, KO, and GO. HK is to FG, so HK to FG is equal to KO to GO. That's corresponding sides are proportional in similar triangles. Step 7, which is our last step, we're going to use the property of proportions. I like to say cross multiply, but that's a property of proportions. HK times GO is equal to FG times KO, which is your property of proportions. So a little similar to doing proofs for congruent triangles, but not the same because we're talking about similarity and not congruence. So we've got some other reasoning that we have to use here in our proofs. So you can kind of get an idea of what types of reasons we might be using to prove that two triangles are similar to one another. Now, in your practice problems, you're going to use the AA similarity postulate to line up triangles, put their corresponding sides together, work with their proportions, and use some mathematics in there to solve for unknowns. So I hope you found this video helpful, and good luck in attempting to do those practice problems.